there'd be a stop point at geosynchronous orbit.
Okay, new terminology. We did this stuff for 18 years and we really didn't come up with too many new terms or anything. Recently, I've come up with the realization that we have to match our terms with the space community so they can start understanding what the heck we're doing. So we
Right.
come up with the terminology spaceports. Oh, wait a minute. Somebody else came up with that.
Yeah.
Spaceport. So our one on the surface of the ocean, we call that the Earth spaceport.
Right.
Everybody buys into that. Yeah, we bring rockets there, we launch stuff, we land stuff and take it off, we load stuff, we do all that stuff, what a spaceport does.
Hmm.
But the beauty of a tether, a permanent infrastructure, is that we could put a spaceport at geosynchronous, release spacecraft, accept spacecraft, that match the velocity, come up, we grab it, we can refuel it, we can fix it, we can store it, we can assembly at a spaceport. What you do is you take 14-ton payloads in each tethered climber. They come up one a day. Okay, one a day. 14 tons. Now you store it at the geosynchronous spaceport, and then you put 10 of them together into a spacecraft. Oh,
Okay, right.
so what do you do with it? Well, you bring it up to our spaceport at geosynchronous, and you get 100 of those, and then you assemble your spacecraft right there.
Yeah.
Okay, so it's assembly, which is a new offering from the space elevator community to the mission people, the customers. We can
Yeah.
assemble your spacecraft at our spaceports. Okay, so we have an Earth spaceport, we have a geosynchronous spaceport designed for space solar power. We didn't do that specifically, but it's perfect for space solar power assembly. Then you go up to the apex anchor at 100,000 kilometers. Now, think about this one, the assembly of a science spacecraft. Well, right now, our first payloads would be 14 tons. Okay. If you look at all the science missions by NASA, none of them were 14 tons. The satellites were 1% of the mass on the pad that went to Mars, Jupiter, Saturn, and are beyond our solar system in the Voyagers. Those things
Yep.
are minuscule. And
Yes.
so our mission, our science mission satellites to our planets around the solar system and beyond have been spectacular achievements of engineering,
Yes.
but minuscule in scientific payloads. So what do we have to do? We have to become the supplier, the logistics chain. Now you bring up to the apex anchor and you launch a 14-ton satellite. Holy shit, those guys at JPL would have Christmas parties for us. But
Yeah.
wait a minute, let's take it one step further. Let's say we put 10 14-ton satellites together and have a 140-ton spacecraft. How much battery can you bring? How many science experiments can you come? Okay, then you put rockets on it to do trajectory stuff along that, but you assemble it up there at our spaceport. So the spaceport at the Earth, at Geo, and at Apex Anchor are the same thing. Release, accept, repair, refuel, assembly, and store.
Right.
So these spaceports are not only on the surface of the Earth like everybody else, but we're also at Geo and Apex Anchor. So we're trying to pass the word on to the space community that we have 3 major spaceports. And they all go say, yeah, we understand that one down there. What are these other 2? We've never called them spaceports before. So they never thought that we could assemble something there or repair or store. So we're trying to get the word across on spaceports as a very critical step in having the space community understand the strengths of space elevators. So your show here is the first time I've really talked about it
Okay.
in the space community. So this is a key discovery. It's more like a recognition instead of a discovery. Holy Toledo, what can we do? The answer is we're a spaceport.